Two blocks of mass 8 kilograms and 6 kilograms are held by like strings PQ, QR and RS as shown in the diagram. PQ makes an angle alpha with the horizontal and RS makes an angle beta with the horizontal. So we've got 1, 2, 3 strings. This angle here is alpha and this angle here is beta. Angle alpha is such that alpha is sine to the -1 of 7/25 and QR is horizontal and the system is in equilibrium. Calculate the tension in the string PQ and hence find the tension in the string QR, and then find beta and then the tension in RS. Okay, if alpha is sine to the -1 of 7/25, that means that sine alpha is 7/25. So sine alpha is 7/25. And then if we use sine squared alpha plus cos squared alpha is equal to 1, then cos alpha will be the square root of 1 minus 7/25 squared, which is 24/25, or that you realise straight away that this is a 7, 24, 25 Pythagorean triple. So consider the forces acting on the 8 kilogram block. So if we do that, you should draw all the forces. So mark on the point Q. This is the tension in PQ acting that way with angle alpha. And this is the tension QR, and then also we have the weight acting down, which is going to be 8G. So drawing a separate diagram will help us solve this problem. We've only got two ways which we can solve it. We can resolve it vertically or horizontally, or in the J direction and the I direction if we prefer. So resolving vertically, then we're going to have the tension PQ sine of alpha minus 8G. This force will not have any effect when we're resolving that way, and that's equal to 0. So we've only got one unknown here, which is TPQ, because we have sine alpha as 7/25. So TPQ will be 8G over sine alpha, which is going to be 8G divided by 7/25, which will give me, taking G as 9.8, that will give me 280 newtons. Now, if we resolve horizontally, so this way, so this time TPQR will take in effect. So we're going to have TQR in that way. Against it, we're going to have T, so minus TPQ cos of alpha. This is why we needed the cos of the angle. Okay, but this time the weight will not interfere. So that will be equal to 0 because the system's in equilibrium, and therefore we can have that TQR is going to be TPQ cos alpha, which is going to give me 280 times cos alpha, which is 24/25, which will give me 268.8 newtons. Right, we're now going to consider the other block, this one here. Okay, so again, drawing a force diagram. So we're going to have TRS, this one here, acting from R, at angle beta. And we're going to have TQR, which we already know, just calculated to be 268.8 newtons. And 6G acting downwards. Again, same idea, resolving horizontally this time. We're going to have TRS cos of beta minus 268.8 is equal to 0. And that's going to give TRS cos beta is equal to 268.8. That we'll call that equation 1. And then resolving vertically, we're going to have TRS sine of beta minus 6. Okay, this one doesn't take any effect. Is G, so 6G is equal to 0, which gives TRS sine B is equal to 6G. We've got equation 2. And what we do equation 2 divided by equation 1. So that's going to give me TRS sine beta over TRS cos beta is going to be equal to 6G over 268.8. Right, obviously we've got TRS here, so that will cancel. And we know that sine over cos is tan, so tan beta is going to be equal to, if we work this out, 0.21875. And then beta is tan to the minus 1 of that, and which gives me an angle 12.339, which is 12.323 significant figures. Now we substitute into 2, or 1, it doesn't matter, we'll do 2. Okay, we're going to have TRS is going to be equal to 6G over the sine of beta. So what we've done, we'll rearrange this. TRS is 6G over sine beta. So working that out on our calculator gives me 275.156. Whatever you do, please don't use the rounded off answer. Use this one in the second part of the calculation. And then that gives me 275.2 newtons as the final answer. So this has been a video to show you how to find the angle and all the tensions in a given system by two blocks being suspended by 2 poles. I hope you've understood, and I thank you very much for watching.